Hi, my name is Jonathan Carter. I'm the Technical Director of Arxan, and today we're going to show you the motivations behind mobile app hacking, and we're actually going to show you some examples of how to actually do it. So first, let's look at the motivations behind mobile app hacking. Why are people doing this? You know, today, one of the key approaches that attackers are using to hack apps starts with accessing the unprotected binary code. Applications are being compromised in a number of different ways through the binary level attacks. And first, we have to focus on reverse engineering. So through reverse engineering, an attacker can gain all sorts of useful, sensitive information about your organization, as well as the design and implementation of your underlying solution. These applications can be reverse engineered back to the original source code, which allows somebody to easily steal your code, reuse it elsewhere, sell something, gain some sort of intellectual property through your content. These are a few of the typical motivations for reverse engineering. The other area of concern is the modification of the actual behavior of the application itself. So a lot of the time, people are modifying these applications in order to spy on users, steal their sensitive information, conduct fraud, or perhaps inject other malicious malware to create botnets through phones, for instance. So now let's explore a few actual attack vectors out there. So here we have our mobile app, and as discussed earlier, we have the risk of reverse engineering. So if we look at some of the common attack vectors for reverse engineering, what we're going to first do is we can bypass the Apple code encryption, which is provided on all iTunes Store applications. And the idea is that this code encryption is supposed to prevent somebody from reverse engineering, doing literal code structural analysis, symbol dumping, key lifting, those types of things. So let's switch to a video where I show you how to actually bypass the code encryption provided by Apple on an iTunes downloaded app and then successfully reverse engineer it. So here we have an app which I've just downloaded. I'm loading it into a reverse engineering tool, and you'll see immediately that it complains that it can't actually reverse engineer because the code is encrypted. Great, that's what Apple wants. The problem now is that we're going to bypass Apple and decrypt the contents using a tool called Clutch. Clutch will take a decrypted snapshot from memory and write it to disk. Once we get that snapshot, we can then feed it into a tool like IDA Pro, and immediately it will have a decrypted, perfectly reverse engineered application available for control flow analysis in this example. So we've used a freely available tool in order to reverse engineer an iPhone application, which in theory shouldn't be allowed. Next, we're going to look at an example in Java Android applications where we can take a final binary and recreate the original source code based on what we've downloaded from the Google Play Store. So let's switch to that video, and we'll show you an example involving a fictitious Bank of Arxan Android application. So here we're loading into Eclipse our development environment for the Bank of Arxan app, and we're just going to show you the original source code so you have something to compare against. So here you can see the make payment method, and we're just showing you this for your own information so that we have something to compare. So when we use a tool called dex2jar, we're converting the Android Dalvik bytecode back to its Java bytecode equivalent. and it produces these class files which get packaged into a jar, and we then use a freely available tool called JDGUI and feed the jar into that GUI. Now, when we do that, you can see how suddenly it's able to create source code based on what it sees in the jar. And when we compare the original code, which we showed you in the development environment, against what we see here in the JDGUI environment, the code is in fact remarkably accurate. So those are some examples of reverse engineering attacks. Very easy to do. I didn't have to spend any money on any tools in order to do this type of stuff. Let's look at the more serious, interesting issues of code modification and integrity as well. First, we're going to look at an example where we're going to actually modify an application and conduct fraud against a user without their awareness. So let's switch to an Android application where we once again have a Bank of Arxan app, and we're going to conduct some financial transactions, and by modifying the binary, we're actually going to be able to trick the user into sending the money from their intended recipient to a hacker instead. So here you can see that we've got a user named Bill who's paying Bob rent of $350. Now what we want to do is modify the binary to trick it into forcing a hacker to receive the money instead. And we do that using Buxmally code substitution. We've translated the code into Buxmally, and it's fairly readable. You don't require a great deal of sophistication in order to understand this code. This is a beginner programmer could do this. Now here we've modified the make payment method, and we've forced the user to pay the money back to the hacker instead. And when we send the payments to the server, what we end up doing is redirecting the money to the hacker instead. So our simple Buxmally modification was a success, and it didn't require a great deal of effort by the user. This was freely available, and really these types of attacks are only limited by the imagination of the attacker. Let's go back and look at another example involving iPhone's method swizzling. So method swizzling is another interesting technology which was an actual feature of Objective-C that allows for code substitution without actually having to modify the original code. So you can supplement the code with your own code if you want. So you can see where this is going. I don't actually have to modify the code in order to change its behavior in this example. So let's look at an example where I'm performing method swizzling, intercepting a method call and replacing it with my own method call in order to conduct fraud. So here, Bob has installed a malicious app on the phone, and this app is actually installing a dylib. And when Bob installs and uses his Arxan application on the phone, these payments are now going elsewhere. Now what the malicious application is doing in the background is placing malicious code in a particular directory, which iPhone is then immediately diverting all method requests to the Bank of Arxan client class make payment method to this malicious library. And in this code, you can see how we can immediately change method parameters to anything we want and then pass the request back to Bank of Arxan for processing. And here you can see that we've actually changed the amount to 50, and we've changed the to field to a hacker. So when we execute this code within the Bank of Arxan app now, instead of the money going to Bill for $50 for dinner, method swizzling will allow us to redirect those funds to the hacker instead. So once again, did not take a great deal of effort to conduct this attack and required no real skill by the attacker. So as you can see, there are very easy ways to conduct these attacks, and mobile applications can and should mitigate against these attacks, particularly reverse engineering and code modification, or integrity violation, as it's also referred. Organizations that do not choose to do this risk a great deal. You can see through our examples how easy it is to steal information, perform fraud. This could also lead to damage of the brand itself through a security incident getting out in the media. You can also result in loss of revenue, intellectual property theft, or the compromise of the user experience itself. So don't risk your business or your customers. It's important to build integrity, preservation, and reverse engineering resistance into your applications before they get deployed out into the wild. And you can do that using Arxan application protection for IBM solutions. If you're interested in knowing more about our solution or you'd like to see a free demo, please reach out to your IBM rep, or you can contact us online. Thank you very much.